All right, we're out here in the woods doing some social distancing and some homeschooling at the same time. We've got Lawton. Can you say hi?
Hi.
He's got his shoes on his wrong feet. There's Aster, and there's their cousin Olivia.
Hi.
And we're out here, you know, it's springtime. Things are starting to break dormancy. We figured this was our last opportunity to come out and try to identify trees in their winter conditions. So we brought the book out. What did we find?
We found green ash, shortleaf pine, sourwood, and sweet gum.
All right, that's right. So we got a lot of different species out here. We keyed out several using the book. Shortleaf pine, of course, isn't in the book, but we figured while we're here, we might as well learn it. So I'm gonna walk down here real quick and talk a little bit about invasive species. Let's walk down the hill and see if we can find something cool. Check out this tree right here. You see my ground blind right there? Just to the left of the ground blind, I've got this evergreen tree. See if you can figure out what that is as we walk up to it. I mentioned we're talking about invasive species. This is not an invasive species, but it's a related topic. Come up here and get a closer look at it. Does that look familiar to anybody? How about that? That look familiar? Those of y'all who had dendrology, you know what this tree is. This is eastern hemlock, Tsuga canadensis. We're actually out here on my property that's adjacent to the Clemson Experimental Forest. How about this property? It's just 7 acres. A couple years ago, and one of the things that I liked the most about this property, that got me excited about it, was that I had probably the healthiest looking eastern hemlock that I've seen in a long time. So if you remember a little bit about eastern hemlock, you know that eastern hemlock has been severely impacted by the hemlock woolly adelgid, which is a non-native insect brought over from Asia accidentally. I believe it was introduced into Virginia back in the 1950s. And then it spread north and south across the range of eastern hemlock and has pretty much wiped it out. I think it showed up in Pickens County, South Carolina, in the early part of the 20th century. The early part of the 21st century. And if you've been up to Jocassee, you've been up to the mountains, it's rare to see a hemlock that looks like this, that's so healthy. So that raises the question, why is this hemlock so healthy when every other one that you've seen has been so severely impacted by hemlock woolly adelgid? And the answer, I think, lies in its isolation. So we're here at the very, very southern end of the range of eastern hemlock. Right? You don't find really any of it farther south from here. We get a little bit of it right here because we're on a north-facing slope, so it's nice and cool and moist. And so we just have an isolated individual that is basically grown up in this era of hemlock woolly adelgid. It's grown up basically quarantined, self-isolated out here by itself, which is one of the reasons, probably the main reason, why it hasn't been severely impacted by hemlock woolly adelgid. Now, when I first saw this tree back in 2018, there were no hemlock woolly adelgids on it at all. And I was kind of surprised when I came out here just a few weeks ago and saw that. Right, so if you look at right there at the base of those little leaves, right, those little white cottony looking balls, those are the hemlock woolly adelgids. So how did that happen? How did these little tiny insects find this eastern hemlock that's so far removed from any other eastern hemlocks within its range? As far as I know, the closest eastern hemlock is about a mile away. So how did these little insects get here? They have no other alternate hosts that they can live on. They can only live on eastern hemlock, but somehow they found this tree out here on my 7 acres. It's kind of an enigma, isn't it? Well, the answer really lies in the ecology of the little insect itself. Right? They're not very mobile for the most part. However, when they are young, they do have what's called a crawler stage where they can move a little bit and they can move from tree to tree. And that's how, like in a riparian zone in the mountains, they can easily, crawl from one tree to the next. But that doesn't explain how it got here on this one little tree out here, separated from all the other ones. If you look at that wool, we're going to call it wool. That's why they're called the woolly adelgids. Right there at the base, these little woolly hairs. One of the things that wool enables the woolly adelgid to do is to travel long distances. It's a tiny little insect, but it weaves this sort of nest, if you will, of these woolly fibers that allow it to get carried long distances in the wind. That's the only real explanation that I can think of how this tree got infested. Right? Maybe a neighboring tree a mile away got infested, and then just by sheer chance, one of those little insects blew over here and infected this tree. So kind of crazy. I guess there's sort of a coronavirus metaphor in all of this, right? So self-isolation does work, right? Works for coronavirus, it works for eastern hemlocks, but it's not 100% effective, right? It doesn't completely eliminate your risk of getting infected, right? These guys have clearly got infected. However, it is just one tree, right? It's not a forest full of eastern hemlocks. It's not a whole community of eastern hemlocks. It's just one. So it was a lot easier for me to get to this early. I'll be able to come back and treat this tree individually with some insecticide, and I'll be able to control this problem because I do want to keep this hemlock alive. Right? There's an eastern hemlock, again, isolated, far from any other eastern hemlocks, yet nonetheless is impacted by hemlock woolly adelgids. Let's talk about invasion ecology a little bit. I mentioned that this species of adelgid is not native to the United States, right? It's native to Asia, where they have several related species of hemlocks, but it does not have these transformative impacts on ecosystems like what we see in the southern Appalachians, where it kills all the hemlocks. We don't see that happening in Asia, in the native range of this insect. And the main reason for that is what we talked about in our invasion ecology lab. That is the enemy release hypothesis, right? So when this hemlock woolly adelgid was accidentally brought over to the United States, we brought it over, but we did not bring over its natural predators. One of its natural predators is this beetle, this native beetle in Asia that feeds on it. When we brought the adelgid over here, we basically released it from that natural predator, and now it's able to expand its population unchecked. There's nothing to keep it in check. All right, so that's a classic example of the enemy release hypothesis. It's also possible that our eastern hemlocks, I don't know this for certain, but our eastern hemlocks, because they did not evolve in an environment where, you know, they ever dealt with woolly adelgids in their evolutionary history, it's possible that they also have no co-evolved defenses to hemlock woolly adelgids. So they're very susceptible to injury and mortality when these little bugs attack them. So that, if that is true, that would be an example of the novel weapons hypothesis from Field Trip 5. So I know Field Trip 5 mostly focused on invasive plants, but a lot of those same principles apply to invasive insects as well. And I think this story really underscores something that we've touched on in class a few times, is this amazing transformative power of tiny little organisms in forests. Right? These bugs will kill this tree. They will kill every single eastern hemlock anywhere. And at a glance, they just look like little harmless bugs. So anyways, good luck with your social distancing. Obviously that's going to reduce your risk of infection, but it's not going to totally eliminate that risk. Here's a nice metaphor. A recently infected eastern hemlock.